will make, right? Now, an operation like finance uh, will partly make operational decisions, but I think on a larger scale they'll have to think very strategically about what are the business decisions we need to make, right? How do you forecast, how do you predict, how do you do how do you do analysis that will help, uh, not the not the post mortem, right? Not to analyze something that has happened, but can we predict, okay, at the rate that we are going at with the information that we have, with what we had, the next 6 months, the next 1 year, the next 2 years, right? Because nobody in the world that we live today, nobody plans for 5 years anymore. It's a 2 year plan. Why? Because business changes so rapidly. Now imagine in 2019, uh, I know we would have made so many plans, but then COVID happened, and now we're in 2021 and still COVID is happening, and now most of the organizations thought it will go away like a viral flu, but it didn't, right? When I spoke to speak to so many organizations in 2019, they were telling me 6 months, but I told, we felt, looking at the data, that it's not going to go away in 6 months, and it hasn't gone away in 6 months. And now you the organizations who made plans in 2019, what if this doesn't go away in 1 year or 1.5 years, what are we going to do? They are far better than the ones who thought it will go away in 6 months, right? So this is the reason I'm saying, you need to use information and make relate that to decision making, right? So the data storage decisions that you make also will fundamentally decide how your business will be in the next 6 months to 1 year to 2 years or even 5 years, right? Okay, so let's dive a little deeper, right? So one thing is, depending on the decision that you make, your strategy will change, right? How you engage with customers, internal and external, and how you develop new products, okay? One of the reasons why Facebook, Google, Amazon, even airlines such as Emirates, Lufthansa, we spoke about Singapore, why they are able to weather certain storms, go through certain phases, make certain decisions, is the fact that they have used data and information to come out with new products, new services, right? Um, even to think about changing an entire industry to cater to certain demands. You can do that if you have data, okay, because you can come up with different business models, right? Then the other fundamental fact with information and storage is the risk, okay? Storage solutions and the risk of cyber attacks, the issues that you have with pure storage related issues, fundamental security issues, redundancies, because data and information become redundant, right? Damaged, inaccessible, there are downtimes. So when that happens, how do you kind of manage, how does your business manage? That is why this whole concept of the cloud came in, no? Because you had so many redundancies, you had so many physical issues, maintenance cost. I remember, back in 2008 when we were talking about, when we were going on this data, basically a server farm concept. How many issues organizations had, right? um, I think at that point I was working with a very reputed bank in the world. I don't want to mention the name. We had to all of a sudden make a very strategic decision to move to cloud, because certain physical locations were becoming inaccessible, there were lots of physical issues, trying to manage physical server farms. So that's why people shifted to cloud, and even within cloud certain regions, right? Now there's a big question, in Sri Lanka also. There was this major question came up, right? um, when certain countries give certain solutions, now you know for a fact, Google and Android has stopped supporting Huawei phones. Why? What was the reason? The reason was there was a security breach, right? So Huawei had to, now they are promoting Android, they are promoting their smartphones on their own platform. Uh, that might work. It has worked to a certain extent in China because the market is so huge. But is that something that you can think about in the next 10 years? Is that sustainable? Still, one of the biggest selling products in China, if you take that 1.7 billion population, is the iPhone. Why? Why is iPhone selling more than Huawei and others? It has nothing to do with security. It has everything to do with usability, marketability, and user comfort. Why are they not using a homemade product? So I mean, these are the things that a business needs to think about, right? Security risk, okay. And now majority of the countries have stopped encouraging products that come out of certain parts of the world. Why? Security risk, right? Because there are data breaches, and there've been hacks, and like especially in Sri Lanka, um, we stand a very good chance because we are known for our we are known for our certain standards in maintaining certain certain standards in terms of security. So our products stand a better chance compared to certain products from certain parts of the region. I will not go into geopolitics at this time, but that's how it gets played out, right? So you need to think about risk. And the thing is this: you can take this very extreme position about risk and think, oh my god, we have to go with the standard one because we have always gone with the standard one. Or you can actually look at the actual risk. And when I showed you that list of service providers for database management systems, all of them, right, all of them have to use standard security measures. That's the beauty of standards, right? People can't just decide what they want and do what they want. You have to because when you talk about enterprise level software, enterprise level solutions, people do need to think about enterprise level risk. Okay, that's what I'm talking about. So the advantage for users like you and I is that now we can buy cheaper options that have very good security structures, right? Those days some of the things that people use may have not had that, right? That's why they had to go for Oracle, that's why they had to go for Microsoft. But now all of the solutions providers have adopted very good security measures, right? So all of a sudden you can buy cheap options, right? You can buy cheaper database management systems if you just look at database management, right? So then another thing that you need to think about is virtualization of the business value, right? So discussion is shifting actually from on premises. It shifted to cloud. Now we are actually shifting from to thinking in terms of the solution to business need. Okay, we are no longer too worried about, the world is no longer too worried about this feature or that feature. We are now worried about whether it meets our business need. So you need to be very very conscious and absolutely aware of what is the business need, what is my business process, what are the critical elements in my business process, what are the things that I must have, what are the things that I don't want to really worry about, right? Then now actually cloud and solution come together. Those days we had to do a solution, find a cloud partner. Now the cloud partner has actually developed a solution which caters to our need. It's a matter of customization, right? Now all the users are now used to cloud as well. Even you and I, we our entire Google accounts, everything is on cloud. You get what, 25 GB or 15 GB of capacity when you actually if you have a Google account, right? Same with Microsoft is now pushing very much pushing on OneDrive, right? 40 GB of OneDrive per user. Saying that please use us. Now those days they were saying no, onboard. Now no longer, right? We are not really needing an onboard capacity in that sense. We can always store it in look at our phones, right? Everything is on the cloud, right? Even if our onboard memory finishes, right, capacity finishes, Samsung, so many providers are offering cloud options, right? Log in, put it on the cloud. So why? Because people are now more used to it. people are more friendly, that technology is more friendly, and people feel that they can be a part of it, right? Okay, so then we are going to talk a little bit about creating business value, because I felt it's important that as business leaders you all need to have this level of thinking, right? So solution providers and their clients will see more software stacks coming up, right? And the availability will shift from more well-known storage to even some obscure names, right? And the whole conversation will be about how do you integrate our business requirement with your solution, and our hardware or available hardware with the cloud-based solution, right? So you're gonna see some really weird names, right? Those days we were used to Microsoft, we were used to Oracle, we were used to certain known home brands, let's say. But now you're going to see some weird names. You're going to see some new software stacks, and that's normal, and that's really good, because that will give you so many options, cheaper, safer. And I would say most of these options are actually safer than some of the more established names, right? For obvious reasons. Then even you will have to now really look at the vendors that you work with, and really look at what is the business value they bring, not the features, not the storage, not those typical software things that we look at, but what is the actual value those vendors can bring. So when you think about value the vendor can bring, value the provider of this database can bring. There are so many data management trends right now, right? Still people are using SSD and flash at an individual level as well as organization level, right? Certain banks, they still use this method. Cloud is very popular, and the hybrid method is actually even more popular, I guess, now. Then there's something called secure storage, especially because of ransomware. I think you'll are familiar with ransomware. So secure storage actually backs up at a periodic level, so that even if you lose now because of ransomware, you might lose all the data. Even if you get a ransomware attack, you have the latest version uploaded in a secure site that the ransomware doesn't have access to. Then tape is still there. It's not so popular, but there are certain organizations that actually use tape still. Then the other more popular storage mechanism that people are talking about is software defined storage, right? And which is scalable, and which is actually a very cheap option for enterprises, right? So when the software evolves, the cloud or the hybrid storage also evolves with that. So you don't have to buy storage and keep for whenever we need. Back in the day, I think if you have some familiarity, people used to buy storage and keep, because there's no other option, right? Even if you have a very small system, you have to buy storage, paying a thumping amount, and tagging up with so many contracts that will run your bank account down at some point, even though you didn't use it, right? There was nothing you could do about it. But now, because of cloud, because of hybrid storage, because of scalable software, you can even start with 1 or 2 terabytes and scale it up, scale the capacity as the software scales. So which is a very cheaper, safe option. So when you think about solutions, when you think about databases and solutions, right, you need to think about some very critical and fundamental things which I want to cover now, and this is what even IT needs to really get their head around, right? Not thinking what is the code level, what is the operational level, what is the security level, because those are actually now handled, right? You don't have to worry too much about it. You just need to really pay attention to the business risk, which is to do with the SLA or the service level agreement by offered by the vendors, right? You really need to be careful when you sign up that the service levels are properly done, right? And they're acceptable, and most of them have very acceptable service level agreements. The problem is, as organizations, you all will really need to start evaluating what is the SLA relevant to you, and not just try to do everything, and just pay either a thumping amount or just not have a proper solution, right? So service level agreements, what are the turnaround times, what are the limitations the databases will have in terms of scalability. You'll have to think about those things in terms of a proper SLA. And I know this term might be new to certain people or may not be new, but you do need to pay very close attention to the service level agreements that you will agree on. Okay. Then this word, scale, right? Scalability of the solution, scalability of the database, scalability of the storage, very very critical, right? And when you scale, what is there a downtime? Are there limitations in data, right? So this word scale stands for so many things, right? The solution itself, can you scale your solution on this data storage mechanism? Sometimes you can't, right? So you need to think about those things. Then performance, right? How many online transactions, are we using massive data analytics, or are we using IoT is Internet of Things, where we use a lot of devices, okay, sensors, cameras, things where you monitor a lot of things. So sensor, and especially in the European region, you have a lot of sensor based monitoring that happens in aviation, okay, especially at even on the tarmac, even with the devices, even with the aircraft, the terminals, staff, airport, in transit, all of those are heavily monitored, and they use a lot of IoT devices, right? I think if you're from IT, you might have some understanding what IoT devices are. Even your phone is an IoT device, right? Because there's so much of information it captures and relates to different parties, right? And IoT is a fundamental aspect of big data, which we will talk about. So you need to think in terms of how many, even if you forget all of that, you need to start thinking in terms of how many online transactions will you do. When I say online transactions, I'm not talking about payment transactions. How many interaction points, how many departments, how many online data calls will you do, right? How much of data analytics will you do? So you need to think about that in terms of your scalability. Then flexibility, which is like a very, it's like a very general term that we say. Flexibility in terms of solution, is it what can it do, what cannot it do, and how much of flexibility do you have, right? Can you use multiple integrations, right? Can you link with different systems? Can you, because you don't have to link with every system, but the systems that you link with, can you do you have that flexibility? If you want to go for a different vendor, if you want to go for a different architecture altogether at some point, does your system allow that, right? You need to think about those things. Then how much of tying in do you need to do with the cloud, right? Does it come on board? Are there any complications with it? What are the risks associated with this? How much of storage do you get with it? And what is the level of storage? Is it and in terms of costing, like if you want to go from one level to the next level, what is the enhancement in cost? So you need to think about the cloud aspect of it as well. Then another very important word is interoperability, right? Especially at national level. Now, since we are talking about the Sri Lankan Aviation Authority, I would like to really emphasize that you do international systems, local systems, right? Interoperability is very very important.
අනිකොලෙන්නේ ගැවි
Okay.
අනිකොලෙත් අයිටම්
Then
10 එකමන තියෙන්නේ මේක එකද
I would appreciate if everyone, unless you are being part of a discussion, if you can be on mute, that will just help everyone to kind of absorb the information a little bit better. Right, thank you. Right, and then another thing that you need to think about, and when I say think about, be be practical. Okay, be practical about internal security, because as I said, most of these solutions are catered in that manner. So sometimes when I work with certain clients, what they kind of think about, and what they go into these discussions about security, and um, the whole purpose of the database, the whole purpose of making information as a metric is lost, because only they are thinking about the security, and they keep just going around the mulberry bush about, no, we have to be secure, we have to be secure. But at the end of the day, uh, you need to be practical about security, right? You need to know what are the security elements that your database, your solution has, and what do you need to have. You don't need to have everything, right? There are certain things, because like I said, some majority are inbuilt, they are taken care of. So you just have to establish the right level of connectivity. That's all you need to do. You don't need to do anything additional to that. But if you just think of security and that's the only thing that is important to you, you will lose out on some of the great benefits of having an interoperability operable system. Okay, then external security. So these are elements that you need to think. So then how do you manage public access, right? Because not everyone needs to have access to your system. How do you limit that? So those are some of the good things that you can think about, right, in terms of the solution is one, storage is one, and now of course both come together in most cases, in pretty much all the cases. So you need to think about how do you think of your business need in terms of SLA, scalability, performance, flexibility, the interoperability of the solution, the tie-ins with cloud, and the internal and external security. So if at a strategic level, this is what you need to actually be thinking about. Then in terms of cloud storage, some of the best in class practices, I just wanted to ensure that we cover some of these points. So one of the things is the standards that the vendor, right, the vendor is actually certified, the vendor is actually adhering to certain security as well as certain industry level standards. So SSAE 16 is a famous and generally accepted, and I think if you look at all the lists that I shared with you, all of them are actually in par with this particular standard, right? And there are many more, right? And you can check with compliance, you can check with certain industry level bodies. They will tell you certain standards need to be met. You need to ensure that the vendor is actually someone who is up to date, and most of the vendors now, these are given, these are things that they are now very much in power of, right? Then you need to also think about how are redundancies managed. Now when I say redundancies, in the database that you have, even on paper, there are so many redundant data. Okay, but now there are so many databases available, the solutions are available, where you can actually redundancies, then security loops, in terms of standard service providers, all of those things are internally managed, right? But you need to be conscious that the solution that you go for talk about these things, right? Then provision to separate internal servers and web servers and run separate instances. So this concept called microservices has been there for some time, of course. So microservices actually manages this really well, right? So that's why I said we are now in a world where RDBMS and object oriented have been coupled into the same form, where you can keep a lot of stuff separated and internal, but they talk to each other even through the web, and so that the people who are using your systems don't feel any different, right? There's no real issue for them, right? Then the other thing is encryption, which is to do with security management. So there's endpoint encryption, end-to-end encryption, and endpoint encryption. So you, even from a technical perspective, even at a business risk now, especially for finance, maybe HR, procurement and things like that, even when you ask questions, make sure your questions are, smart in that sense, right? What's the encryption method that a certain vendor uses? So there are different, there's token, there's auth, there are different types, right? I don't want to go into technicalities, but there are different types. So you need to ensure that they are aware of it and they're taking care of it. And if you go with the standard one, you can see that they actually pretty much adhere to the standard mechanisms that are there, right? Then another important thing is clustering and load balancing, right? How many I know I worked with I worked with ICTA for quite some time. One of the biggest concerns that we had when we were working on some of the projects was this load balancing, right? All of a sudden you see that the site is down. Why? Because there's no proper load balancing, and that's a very simple thing to do, right? Then clustering of information, right? So you have clusters of information, so that even if one part goes down, the other part is active, right? But sometimes everything is down, right? People can't access it from outside. Internally also you can't access. So then there's a huge risk, right? So you need to think about these so these are some of the things that you need to think about, right? When you talk about cloud storage, in a very practical sense. So that I thought it will be good for you to kind of get an idea of this. So any questions, anyone? Tivanka, Sampath, Renuka.
No.
So am I making sense, guys? Is it too abstract, or okay? So I will move on, and we'll can come back to any. So if you have any questions, please don't feel hesitant to ask. You can do that, right? So I'll just talk about in terms of security side some of the things. Now so all of this what I'm covering, everything that I'm covering at the moment, forget the systems, right? Forget any systems. Even when you think about, okay, let's say, okay, famous thing is, a lot of people tell me IT is telling that they are implementing a system. And God knows what they are doing. So don't get upset with me if there are IT people here, right? So this is what people usually come and tell me, right? IT system so the whole point is, when somebody is implementing a system as at a strategic level, we need to ask some strategic questions, right? We need to ask some relevant questions. So why I am covering some of these elements is so that we ask those relevant questions, and we ensure that our information, our data is at the place that it should be, right? So these things that I'm covering today will help you to do that. Okay, excuse me. Right, then couple of things so there are three things that we look at. One of the more critical things that we look at is this is if you're in compliance, this will be part of out of your day-to-day life. So confidentiality, integrity, and availability, those are the three fundamental things that we look at in terms of a database, whether our database is compliant to these three areas, right? So confidentiality, if you look at it, so maintaining confidentiality is enforced through encryption, both data as well as the information on it, transfer whatever information that gets stored as well as transferred. In case there's a breach, have we ensured confidentiality was maintained, right? Because it's our data, it's our information. It could have very sensitive data which can basically topple even governments and countries. So we need to be ensuring that our confidentiality is maintained. So one of the things that we look for is how confident, how the system, how the solution ensures confidentiality, right? Then the other thing is data integrity. So the whole point is ensure only authorized personnel are allowed to data and logs, and certain Now if it's a database, I should not have access to everything. I should have access to what is relevant to me, and there should be a separation, right? So, and there should be some level of monitoring as to who access what at what point for what was the reason, right? And so that there's no data breaches, there are no internal security concerns. So that's what we try to do with integrity. And then the other most critical element is availability, right? And availability is something that sometimes people don't think too much about. So it should be available to users, it should be available to administrators, which will ensure that there's very little downtime, right? That's why I spoke about those SLAs. I spoke about I spoke about SLAs, flexibility. I spoke about interoperability. Those things matter because we want to ensure these three things, right? That's why I spoke about it first. And then just a little bit about standard data security mechanisms. Uh, think in terms of authentication protocols, right? There are many authentication protocols which are very good, which are very standard. So you do need to think about how your solution is authenticated, how does it authenticate some of the information. Endpoint security, right? What is the strategy? There are different strategies that you can use. You need to think about endpoint security strategy. Audit trails, right? Some people are hell-bent on audit trails, they forget everything else. Audit trail is one part of it, it's not everything. And access monitoring, it's another part of it, it's not everything, right? Then the other thing is data segregation, what we call subset management, so that even if one part of the data is lost, you have other things which are existing, operational, manageable, and people have access to, so that the entire system doesn't go down, and you don't lose everything, right? So that's why we segregate data into several spheres, and we call it subset management. So there are different ways you can do this, right? There are different mechanisms that people can use to subset manage, but ask these questions, guys, right? Ask, okay, how is subset management manage, how does it do? So microservices, if it uses a microservices architecture, then subset management is pretty much managed on its own, right? How does it manage audit trails, how does it manage access, how do we ensure endpoint security is guaranteed, how do you ensure authentication protocols are followed, what is the mechanism, right? So those are the questions you need to ask, right? Then some other ways like antivirus software, anti-spyware, pop-up blockers. Now if you simply go to your Windows system, and if you go to security settings, and if you go to protection, etc., all of these words will be there, right? There's anti-spyware, there are pop-up blockers, there are firewalls, all these things they're managed, right? That is why you actually don't need to, if you're using your own okay, some people might find fault with me for saying this, but you actually don't need to spend on buying third party uh, antivirus and anti phishing software. Microsoft itself, if you're using a Microsoft system for your personal use, not at office, if it's for personal use, the that the system, the security preventive methods that it comes with, Windows Defender, etc., is more than enough. You don't have to spend additional money. And if you use a open source system, basically malware is not even heard of, right? That is why I prefer to use open source compared to Microsoft, because it cannot do anything pretty much, right? Unless you want to put something on it. So there so many options are there, right? So that's why we say now it's a very open, it's very easy now, not like those days, to actually manage this sort of interventions. And then the other thing is the cost factor. um, One of the things that people do need to really be conscious of is, when you have unsupported databases, there's a huge cost, underlying cost that happens, that hits the bottom line, that people don't really think about. And there are so many compliance risks due to security breaches and data related redundancies. Easily an attack can happen because you have so much of redundant data. and easily systems can crash because you have so much of compliance issues, and basically you opened up the system to have so many risk elements, right? um, then there's something called these license upgrades that we do, and sometimes when you do that license upgrade there are so many disruptions, so you need to think about when you're talking to your vendor, you need to think about these sort of elements in terms of database, right? So sometimes you have database instances that are no longer fully supported, but you don't know, right? You may not know it. Okay, let me see. Any special reason why Microsoft products are mainly affected with virus? Okay, very good question. Okay, superb question. Let me answer that before. Okay, so what happens is, to answer your specific question, any special reason why Microsoft products are mainly affected with viruses, worms, and whatever, but not Apple or open source funds? Okay, good question. I like it. Let me give you a little bit of understanding in terms of how Microsoft has come to be where it is and why others where others are. Okay, so Microsoft, when they started, and even now, they have gone through certain evolutions. It's a highly we call it a highly susceptible solution because of the very code base it uses. Okay, initially it started off with a QDOS, right, quick and dirty operating system, which got evolved along the way. So they were more concerned with GUI level rather than the back end of it. So it opened up a lot of areas where somebody could easily hack into the system. With time and with so much of effort, I know that Microsoft has come a long way, which kind of has secured their backend. Right? When I say backend, I mean the actual operating system, not what you see on your screen. Right? There's a operating system in the back end of it, which is now mostly 64-bit. It was 32-bit, now this shifted to 64-bit. But what happens is, because the system is it's a very bulky system, guys, right? Microsoft is one of the most bulkiest system. If you take your home PC and if you go for an update, it's about 40 GB. Okay, 40 GB update, that will basically kill your data plan also. When you update, just have a look when you're updating, right? And what happens in most cases is, if the update doesn't go through properly, the system crashes, even Windows 10. Okay, why? Because there are so many dependencies which are legacy systems, right, which are legacy in terms of their build. um, it uses some very legacy thinking still, even though it looks kind of very nice and all that, when you when you use it. uh, that is one major reason why people have gone with open source. Okay, open source actually is a very light system. It's and even Apple, to a certain extent, is very light in terms of the bulkness and in terms of the resource utilization, and even some of the technology, very specific technology they have used. Okay, um, and what happens with open source systems is, um, because it is at a very basic code level and not trying to do too many things with it. There are security, like, for if you take Linux, if you take Linux or Ubuntu or something which is open source, um, everything is at a code level, right? Even for you to yes, there's a GUI, and someone with relative understanding can download certain things through whatever. But um, for someone to take control of the system, for malware or to spyware or to fire basically sort of Trojan horses, or now of course Trojan horses are not there, but even at that level, somebody needs to take control of the code base. Okay, the actual back end of the system. uh, these systems, Apple and open source, are very they were conceptualized from a very good thought process, because they've done it in that sense. They've built on top of that very secure base. Because they've done it like that, you have very little option, you have very little open room. There's technically none actually, that malware can get in. However, yes, because of the legacy thinking that Microsoft started with, and they copied so many things from different places, and they're still trying to work things through. Now, now Windows 11, or now of course they call it something else. Windows 11, they say they have addressed most of those issues, but I don't know how far that is true, right? But especially when it comes to enterprise level, one of the biggest risks that you have with going with Microsoft is that it has so many loopholes. The loopholes is pretty much because of the technology they have used from that day and age. But why we encourage open source solutions for enterprise level, and of course Apple of course is pretty much at a user level, is the fact that their technology is very sound, right? The management core, the security levels they have introduced, two-way authentication, token management, things like that are very I mean they're thought out very nicely, and there's a proper structure to it, and there's a standard to it that they have maintained. That is why we say go with an open source, you are far better off, right? Even though people still go for Microsoft because of people feel it's easier to use, but if you actually use Google, and if you actually use Google related services, which comes free, Google Docs, Slides, etc., you will realize that why on earth am I paying $120 now or something for Microsoft Office, Simply Office, every year, right? Or at a license rate, at a corporate level even. So I mean, people are still not used to it, right? I use both because I use both. I understand how easy it is to do work on a Linux machine compared to or even an Apple machine compared to Microsoft, right? I mean, because we are used to it, we tend to think that's the only thing that can be used. So I hope I answered your question there. So I mean, coming back to some of the stuff that we were talking about. No problem, David. So thanks for that question. I think that kind of helped a lot of people. The other thing that I do want to kind of focus on is most of your systems, even the stuff that you run now, have so many unsupported databases. And what happens if you don't really pay attention to it, your annual cost, your licensing cost, 1/3 of it is actually paid for unsupported services, right? So that's why I spoke of these SLAs and all of these things before I came here, because those are the questions that organization needs to really ask, right? Then the thing that we kind of encourage people to do in terms of reducing their cost overall is, whenever you are thinking of a new project, right, new database or new solution, always use alternative databases which are on open source, which are pretty much on RDBMS, right, which are relational database, right, or object oriented, which is still fine. And then so these ones are secure, scalable, they are extremely well supported with a lower cost. Licensing rules are not so complex, not like Oracle, not like Microsoft SQL or anything like that. They're very pretty much standardized, right? So what we want you to kind of think about is think about the fact that you may want to just move to independent support services when you're thinking about performance, tuning, interoperability, security, and etc. Right? So if it's a new project, always start off with a alternative system. Don't always think about the legacy systems. And then if you're shifting, think about a legacy system which is independent or which is independently support, right? So rather than going with the main vendor itself, think about an independent way of getting some support, because then those are 24/7. They have their own way of managing interoperability and tuning up the services as well as the security support systems, which doesn't really have additional cost, right? So we kind of don't want to kind of bottle ourselves into going into hybrid systems at the beginning, but that's the new trend. So think about using a hybrid approach where you use independent services to manage your legacy systems, and all the new projects you will push it onto ORs, or like object oriented database systems, or very much open source RDBMSs. So think about that, which will help you to reduce significant cost, right? I'm saying significant cost, right? You're looking at millions of dollars compared to thousands of rupees. Okay, so it's quite a big cost. So the other aspect of it, so if you have any questions you can always ask, please do. um, then the other aspect of running sort of data modeling, um, especially when you think about when you think about an enterprise level, is we now talk about this enterprise level data models, right? That is simply because you want to have you want to have your data at an enterprise level. Okay, it's not just it's not small corporations anymore. So what we think of it is this concept called business modeling. Okay, that is where business users are needed, like you all, right? um, there are people who are in the business, who are in operations, who are using who will use these systems, need to think of the business model that they need to have, right? So we bring in a lot of business knowledge into the modeling of the database to create an enterprise level design thinking. So this is what I mean. There's a concept called design thinking. I don't want to go into too much of technicality. You will have certain consultants, you will have business owners who will get involved with the thinking of the database, thinking of the solution, before people start thinking any technology stuff, right? So I'll take you through a little bit of this process. There's something called there's this thing called the data fabric. Okay, so a data fabric actually makes it possible for applications and tools to be designed in ways that you think about interfaces. You think about how you will interact with different systems. Things like if you're in the IT world, you will have heard about these things called REST APIs, right? Now it has been there for a while, but that's what people go for. No longer are we looking at we are not looking at direct connections. We are looking at REST APIs, right? So the when you think of the data fabric, and obviously some people with technical knowledge have to do this, must be able to capable of being enhanced to support other standards, right? So all of these things that I'm talking about, right? Network file systems, representative databases, distributed file systems, and different service levels. When you think about your database, when you think about the solution, we bring all of these things together at an enterprise level to think of a solution. We don't look at one single department. We don't look at what only one person does or one department does, or how the system should cater to them, others just follow. No, we look at the entire enterprise and we design a system that talks about all of them, right? So that's why I think one reason why I think all of you are here today is that this is important to everybody. Then when you think about a data fabric or a enterprise level solution, you need to think about combining data from established systems, right? Regardless of size, future requirement. So you think about scalability and make data available to all applications, right? And that's very, very important. Then speed, scalability again, and reliability. Then you think about multiple locations, right? No longer are we required to keep data where we can see it. There's no requirement like that. However, we do need to be conscious of where is our data stored in terms of locality, right? Now, if you take Amazon, if you take Microsoft, all of them, they have different data centers which are on the cloud, operating from Singapore, operating from US, operating from different parts of the world, which gives a lot of security in terms of data security, right? So that data doesn't get lost, data doesn't get misused, and there are cost differences also, right? If you use a Singapore service, that will be a little cheaper than trying to have your data center in the US. Why? Because proximity, data connectivity, all that is a little cheaper, right? So people actually, when they go for enterprise level solutions, that's another thing that you that strategic business thinkers need to think about the locations of the data, right? Then we talk about this unified, creating a unified data environment. So we want to think about global things, right? We don't want to just think about our company, it's in Sri Lanka, it's only, no, it's not. We want to think about global standards, right? Making files easy to files to access, to modify, strong level of security. So we always go with these global standards, right? And we should think about multiple, how does our data model work with multiple companies. Imagine you need to link up your, let's say, civil aviation authority is thinking of doing a database system of sort. How will you link with Interpol? How will you link with certain security agencies? How will you link with certain international weather and weather and disaster management, disaster recovery processes? How do you link with them? Those are things you need to think about. It should not be thought in terms of Sri Lanka and Sri Lanka alone. How do you link with international? How do you link with global players? So the global perspective also needs to come in, right? So there are data backing up, support application development. Then there's something called this multi-tenant architecture, right? Multi-tenants are multiple companies, so they may have access to your system, you may have access to their system. How are you going to manage that? All of those things need to be thought of, right? Then the other very interesting thing is the high level of reliability and availability that you try to create. Again, remember our three main things, right? Availability, confidentiality. So all of these things, that's why these words, they come in different forms, right? Then how do you ensure that very critical segments of data are kept available, kept secured, so that you don't have to worry too much about doing it manually, right? So does the system take care of it on its own? That's something you need to consciously think about. Any questions? Anyone do you all have any questions that you all want to verify? Anything? Anything at all? You can ask. I'll move forward. You can please stop me at any point and you can ask, right? So I'm going to talk a little bit about enterprise level database management. So this is called the enterprise data model. It's called a EDM. Now pretty much everything runs on EDM. I'm just giving you some concepts only, right? So it's a single integrated definition of data, unbiased of any system. So here it's not about Oracle, Microsoft or anything like that. Initial thing an organization has to do is to figure out their enterprise data model, right? That's like a most critical fundamental thing. That is why you need engineers, expertise in-house to think with certain collaborations from outside people. What is our enterprise data model? Don't even think of a system right now. It's about data modeling, right? It is independent of how the data is physically sourced, stored, processed or accessed. The model unites, formalizes, represents the things important to an organization as well as the rules governing them. Okay, so this is the fundamental thing of an enterprise data model. An enterprise database management system is designed to be accessed by 100 to tens of thousands of people. This can include large corporations with few thousand employees, busy web servers. So especially at your level, especially when you're thinking of the national aviation, civil aviation, that sort of a gamut of things, this enterprise level thinking is, I would say, the most critical thing that you need to think of, right? Most of the systems that I've seen in the government sector have not even thought of enterprise level thinking, right? Because the biggest enterprise in any country is the government, right? That's the biggest enterprise, the biggest entity, the biggest linkages that works and cut acrosses government to public sector to private sector, right? So to regulatory bodies to international level. So you need to really think through your data model enterprise data model before you just start looking at get this system or get that system, right? Otherwise what will happen is you'll have so many dissected systems and life will be miserable in terms of managing information, right? So couple of critical things that you need to think about when you think about a enterprise level database management system. There are three things, right? There's something called the conceptual data model, logical data model, and the physical data model. I'll just go one by one very simply. So the conceptual data model is data models. The data model defines what the system contains. This model is typically created by business stakeholders, data architects. The purpose is to organize, scope, and define business concepts and rules. So you are thinking simply about the business, right? What does my operation, what does my organization do, what are the processes, right? HR, procurement, finance. In those, what is the data requirement, what are the interactions? So you are not thinking about any system, you are thinking about the process. How do you provide service, how do you do XY, like that. Then from there you take it to the logical level. The logical defines how the system should be implemented regardless of the database management system. Now you're not looking at, again, you're not thinking about any system, you're thinking about how should it be, how is the model. This model is typically created by data architects and business analysts. So initially you have the business users, now you have data architects and business analysts. The purpose is to develop technical map of rules and data structures, right? So we'll come to that, what those actually mean. Then you do the physical data model, right? So this data model describes how the system will be implemented using a specific database management system. So now you are looking at the ground level, right? You are looking at the actual database. This model is typically created by database administrators and developers. So these are software engineers, software and architects who are at that level. The purpose is actual implementation of the database. So this is the process that one needs to follow if you are to you need to conceptualize, you need to logically think of the data model and physical data. So at any given stage, the business owners will be brought in to get their opinion on what they feel is the right thing. So they may not be able to add a lot of value here, they will add a great deal of value here, right? Process ownership actually is at this level. Then the logical model, they may be brought into just to see whether the logical concept makes sense, but you may not be able to add a lot of detail here. Here definitely you are looking at a very engineering level intervention, right? So from what to how and actual, right? Actual database, right? Okay, I hope that was clear. So this is just a simple model of what we mean by these layers, right? So you have the logical layer, you have the physical layer, and you have the create the actual the business rule layer, right? Most people don't still struggle with I want a system, but before you can even think of a system, you need to think about the business process, you need to think about the data that you're using, the linkages, the business linkages. Then only you can go and think about the data requirement, the technical requirement, the performance requirement, right? So the logical data model looks at the logical modeling and the physical data. The physical model looks at the physical modeling and the create and update requirements. And at the business rule level, you look at what is the data that you need to, what is my process, that's what you technically look at, right? I hope this is a little this is clear. If you have questions, you can ask. Don't think too technical about it, but just understand the core concept of it. So then I'm not going to talk too much about the conceptual model. This is in your booklet, you can read through. So there are attributes, entities, relationships, right? Even if you don't think of any system, you can actually think about this, right? So then let's say if you use a very simple example, you have a customer, you have a product, and the interaction between them is a sale. So at a very basic starting point, you will have a customer name. The customer might have a number, some sort of a reference number. Then he wants to buy a product. The product will have a name and a product will have a price, and the interaction is defined by a sale, right? So at a business level, this is what you try to kind of understand at a very granular level, right? Then in terms of conceptual modeling, this offers organization-wide coverage of the business concept. This type of data models are designed and developed for business audiences. And then in terms of data storage, capacity, location, all of those things are considered, and you try to bring the real world concept to this particular model. So I'll just go into a simple thing. Let's say if you take a customer and the product, you have an interaction which is called a sale. So the customer name can be defined as a string. Okay. Customer number, it will be just number. So this is the level of thinking you need to do. So you have to bring it down to a very granular level of designing the system. So when you have this, you can go into the physical model where software writers, software developers will think of the technology to use, right? So I don't want to spend too much of time on this. So these are technologies, these are methods, they call it in software terminology. These are methods that they use. So you can use these methods to develop the software, but because you have taken the conceptual approach, the logical approach, and the physical approach, your database is nicely brought up rather than just just put together with something, right? So some of the things that you need to think about: open and compatible with existing databases and database tools. There are many tools. I don't have I will not go into all of them or any of them actually, because you can talk about it till tomorrow morning, right? And we always think about open models, right? Some of the models are very closed, and you have to be very careful when you use those models because you can't expand on it. Then customizable for needs of specific departments. So certain models will work well with HR, certain models will be very much relevant to if you have done like a now if you take IFS, they run very their models are, or their solutions are more geared towards the finance sector, and so some of the models they use are more finance related, like that, right? I'm just using a very simple example. Then powerful enough to scale up along with the needs of the business. These are questions you need to ask. Secure from outside threats and data leaks rather. So these are some of the techniques that you need to think about. So how you need to think about how does it secure from data threat, from outside threats and data leaks. What is the open mechanism they use? How is it compatible? So simply because it's open, it doesn't mean it's not secure, right? එහෙම එකක් නැහැ. අපි සමහර කට්ටිය හිතනවා මේක open කිව්වම secure නැති නෑ. එහෙම නෑ. There's open systems which are very well secure. So you have to find the balance. Then the other thing is you need to think about productivity, security, compliance, integration, and again we are thinking of APIs and REST because you need to that's the simplest and the most flexible way of actually integrating systems. How do you manage certain administrative tasks in this relational database, because gone are the days where you have 100 administrators looking at it. Then the other thing is the support. What is the level of support? So we spoke a little bit about support before. Scalability we spoke about again, and latency management. So latency is where how much of data delays, how long does it take to up the system. Sorry about that, guys. How long is the downtime? How long is the management of certain elements? So that's what you need to be thinking of. Then the other thing is at a policy level, I'm sure you have a data usage policy, but I just wanted to cover this so that you will walk away with certain fundamentals. What we want to have is at a very granular level, you want to think about the data technologies and the databases, the layering of it, and I'll talk a little bit about it. Classify sensitive data and identify sensitive data. What are the risks? What is that data? What are the things that are sensitive and confidential to you? And then obviously have all of this in a data usage policy, which has to be a comprehensive policy where people who use the system, people who administer the system have a set of policies that they are governed by. So if you really look at this three layer architecture is where you have a client, you have an application, and you have a data tier. This is a common thing. This is like now in every system. They this is the system, this is the architecture they use, right, which is called a three layer architecture. You don't have to worry about it too much now, because pretty much everything comes with this sort of a model, right? No longer are we doing hierarchical models and all of that. Then the other aspect of it is, these will be a little bit more interesting and uh, applicable to you. For people who are into implementation, you need to think about, there's this service called container storage, right? It's not new, it's quite old actually, right? There's something called Docker, Kubernetes environment. So what happens is, when you use these technology, all of the data is in containers. To use a very simple and a layman way of explaining it, they are in containers. Because they are in containers, certain things which are more relevant to environment, like now one of the biggest problems you have is, you build a system, that system is on development, then you will get a UAT, you get a user acceptance testing on a staging environment, and when you try to put it to a production environment, there are multiple issues, right? You can never get it up and running in the proper way, simply because um, the technology that is used is not the proper thing. So that's why now people are shifting to Dockerization, Docker and Kubernetes, because what happens is, uh, the system itself handles transitions, right, from development to quality assurance, to staging to production. These will have its own structures built up. You just have to just do the management part of it only. They build up the structure itself. So that's a very, it's quite advantageous to save time and to save all the the panic that happens when you're trying to build up systems, right? Then there's this something called the microservices architecture. Read a little bit about it. I will talk a little bit about it, not too much. This is famous, and this is the for many of the service industry, this is the microservices this is the architecture that people go with nowadays. Then we are going to talk about artificial intelligence, machine learning, deep learning, and a lot of automation that happens nowadays with a lot of systems. And this deep learning is a very interesting concept, which I will talk a little bit about. I'm just giving you some of the trends that are happening in the world, and edge computing, which I will talk a little bit in detail, right? And IoT devices, right? So this microservices architecture, actually, if you think of these as separate departments, um, or separate segments in a department, even you will separate it by services and databases specifically for that particular purpose. So what happens with that is, you will have a user who's at a different interface. You'll have certain there's something called API gateways that you use, and you will link these services so that let's say this service breaks down, you have no issues working with the rest, right? It will just work on its own. Security is maintained on its own. You don't have to worry too much about oh my god, the system is down. Very rarely the system will go down, because you're using a microservices architecture. And you can deploy, like if you want to link this to a separate service altogether, you can do that as well. So a lot of flexibility with microservices. Read a little bit about it if you're interested. Then this will be interesting for most of us, because this has to do with a lot of practical stuff, right? In terms of data. So imagine we are now, I think we are talking a lot about IoT and making a smart environment, all those things. Imagine if you have your data center, and within that and outside of that data center you have a lot of smart devices. Okay, one could be your phone, others could be a lot of connected applications. You could have traffic lights which are smart. Of course, in Sri Lanka, I think they were trying to do something, but I don't know where it went actually. Then you will have a lot of smart buildings, power grids. Now I'm not too sure how many of you are using it, but do you know that uh, elect Leco and I think CEB, they're actually promoting smart meters, okay, that can actually connect to their system online, so that you I mean, at a very simple sense, you can at some point you might be able to go and see your bill online and pay for it online, and you know, that visibility, that transparency is maintained, and you can operate it from anywhere in the world if you really think of it, right? So they are trying to do that. I hope that is successful. Then you have smart factories, transportation systems which are interconnected. So what happens is, at a very far away place, you have this edge gateway server, okay, so which connects with these devices and which relays information back to your data center. So imagine if you are in a, so if I take an airport, imagine if you have these sort of, if you have done it, if you're done your system to think of all of these, how much of information you have to make very critical decisions. Imagine it's a emergency situation, or you want to monitor certain things at a certain terminal. There's a specific flight coming with a lot of, you know, let's say even this COVID situation, right, from a high risk country. So with that level of information, because it's captured at that level, you can make very smart decisions which are then and there, right? You don't have to wait for a month of analysis to make a decision. So that is what edge computing actually tries to do, by linking smart devices to a specific gateway, and through that gateway linking to your data center, you create asymmetry of information, right? Information is available right now, right here. Now imagine if you can know the temperature, the humidity of where I am at the moment, right? What sort of information that will give, what sort of decisions can you make with that information, right? So all of that is possible if you have what is known as edge computing. So that is why I thought it will be interesting for you to kind of know this concept. Edge computing is used heavily in the AI world, artificial intelligence world. So this becomes the physical aspect of artificial intelligence, robotic learning, robotic processing. All of them uses a lot of these technologies. So I don't want to go in too much of it. So you have the cloud layer, and at the very end you have these smart devices, smart capable devices, you say. Then you have an edge layer of computing, and then you have these nodes that connect all of them. So this is another structure that this cloud networking uses to ensure that data is available. So in many industries, farming, agriculture, aviation, all of these industries, especially outside of Sri Lanka, they use this a lot, right? You would have seen certain things in India, how they use drones, how they use smart sensors in agriculture fields to actually know which crop. And now I think with what we are trying to do with using what is this, using non-harmful um, maneuvers of, to mechanisms to grow food. uh, you need data to do that. You can't simply do it. You need data. You need a platform. You need some infrastructure to do that. But it's possible. It's possible to do, right? Any questions on those sort of stuff before we move into advanced analytics or anything?
Yeah, Chintak, one
Organic
question here.
fertilizer, exactly. Thank you. Sure.
Hello, can you hear me?
Yes, go ahead.
Yeah. Now
Yes,
on
I
this
can hear
edge
you. Go right ahead.
on this edge computing, now we have distributed edge servers, right? So
Yes.
now it has to be sync with the central database.
Sure. Yeah.
How quickly is that happening? I mean, what is the frequency? Is it real time or once in an
It's real
hour or
time.
something?
It is okay. Okay. No. It is actually real time, but in data there's nothing called real time. Sorry, I couldn't catch your name. Um,
Devinder here.
Yeah, Devinder. So Devinder, okay. I mean, yes, we call it real time, but there's in data there's always a delay, no? Right? There's no real time in that sense, right? So it's conceptually it is real time. It happens then and there. what happens is, in terms of the devices, so there are different types of devices. There are devices that actually work on on very sequential basis as well. Like you say, every hour they will send data. The technology that that particular data, that particular device uses is a little bit more backward to something like, sensory perception devices. Sensory perception devices, if you think of it, are very ambient to the current condition, and it's like within a few minutes, not within a few minutes, within a few seconds you will have the data pushed back to the main server, and the algorithm can run the whole thing and give you the results then and there, right? Real time systems, when they now for weather, now agriculture, now especially if you take certain systems in Israel, uh, they use a lot of real time systems for agriculture and security. I'm sure you are aware of it. So especially in terms of agriculture, they use a lot of variant systems. Now in some of the parts that I worked with in Indonesia, um, okay, so if you look at between 12 to 2 in the evening, you can't work, right? Because it's so hot. People can't work in the field, so we use certain, for us to kind of gauge how the crops are doing and all that, we use certain sensors which are part of the sensory system itself. And then at between 2 to 6 in the evening, every day it rains, and the soil content changes. So that also we use certain sensors which are out there in the field, because you can't get people to go there, right? I mean, these are acres and acres of, what do you call, harvesting that you need to do, and agriculture based systems. So you use a lot of sensors which are, okay, when somebody says real time, that's why I take a leaf back and say, okay, it's not real time, but yeah, 15-20 seconds, with connectivity and etc. You have to give it at least 15-20 seconds, connectivity, that data gets uploaded, for the system to make a rational decision in terms of the algorithm that it needs to run, right? So now some other things that I'll speak about in the next few slides will probably give you a bit more information in terms of how much of real time systems are practically used in certain places, especially in airports. Devendra, did I give you a decent enough answer?
Yeah, I think Chinga, now in case of these IoTs, right?
Mm-hmm.
You are communicating with the, let's say, a signal light. The vehicle is communicating with the signal light, something like that.
Sure, sure.
So if that is going to happen, then it cannot be synced with 15 seconds with the central database, right? It has to be on the spot.
No, so it's like this. There in technology, there's nothing called on the spot, no,
Yeah,
right?
yeah, agreed. Yes.
Right. Yeah, that's why I say, that's why when somebody says it's then and there, you know, I'll use a very simple example. Let's take GPS tracking, right? In
Mm.
GPS tracking, the best the best technology that you have takes minimum 5 seconds to connect with the data servers, right? I mean, I'm talking about the best technology that, I mean, very few people can afford, right? Very few companies can afford, right? And what is the security? What is the guarantee that we give? It's good within a 5 meter, radius, right? Your GPS, if you use the best technology, with the greatest latency capabilities, it's accurate to 5 meters, and it at the greatest level, it will take at least 5 seconds for it to connect to the nearest satellite and to relay that data. So that's why we say it's actually a 10 to 15 second delay, right? I mean, it's not on the spot. So when you talk about data transferring between vehicles to a smart device, let's take a traffic light, right? um, even at that level, you are looking at about a 10-second delay. I mean, it's like this, right? That 10-second delay, even with that 10-second delay, the amount of decision power that you have compared to now is huge, right? I mean, we should not be thinking it should be real time, because in a way it is real time. But what is the decision power that you have right now? You have zero decision power now. But imagine if you have this level of data, your decision making power goes up to about 95 to 98%. It's a 2%, that you don't have that level of I mean, you will never have that level of data, right? That's a given. But Devendra, if you really look at it, the power of information, the power that it gives you as a decision maker is massive compared to what you have now. That's why we encourage people to kind of go into that level of infrastructure, right? So that you make very relevant decisions, right? Right now, I mean, imagine the sectors that we have. Let's use a simple example: agriculture. Now, this whole decision about using organic fertilizer and all that, right? I mean, we all know, right? Let's be honest. The whole decision, it's a great decision, but implementation, why are we having so many issues? Because the data is wrong, right? Data is not accurate. And if you look at the data from the world, it will tell you that your data is wrong. I think that's what we missed it. Super decision, but you need at least 15 years of implementation time for it to come to a level where 4% of national production is of organic nature. That's, I mean, I'm talking with stats from places like Australia that have been doing this for the last 40 years. Okay, so I mean, that's the comparison, right? So I mean, that's what I'm saying. So, but if you had that data, your decision power would have been far greater, no? Right? So did I answer your question, Devendra?
Yeah, thanks, Chintakya. I think
Okay,
yes.
cool, good. Okay, so we'll go into some very interesting case studies a little later. That'll give you a bit more insight. So right, so I'm going to talk a little bit about advanced analytics, machine learning, and AI technology, because I think that those are things that we really need to kind of now think about, and that's one reason why I'm sharing this information, right? So having different, you might be having different ideas about it, so I thought I'll just kind of make it very simple for everyone. So we are going to talk about big data, we're going to talk about analytics, and we are going to talk about decisions through analytics, right? So when you think about big data, I'll come to that, but what you need to think about in terms of big data analytics is these are concepts called data science and data analytics. Those are very fundamental concepts. Data science and data analytics has been there for ages, and now we are actually really using the capabilities of this science, right? That's what analytics through big data is doing at the moment. Then decision support systems, right? uh, I know we have heard of this terminology called decision support systems about, I think about 15 years ago also, or maybe 20 years ago. But now we are actually using very smart ways of doing it, and it becomes very applicable. So I want to talk about this paradigm a little before we go into further stuff and think too many things. Let's just understand some of the basic concepts, right? One of the reasons why we talk about big data and analytics is simply because this concept is purely driven by business outcomes, and that's the beauty of it. It has nothing to do, it has, yes, the technology comes from IT and technology in that sense, but we are actually looking at business growth, right? Acquiring, growing customer bases, retaining customers, because it's all about using information that you have in a very intelligent way. You can personalize it for, you can use personalized information, you can use it for profitability gain. Retention is a huge concept behind AI and why AI is used, and acquisitions of new businesses, new clients, right? Even if you think about some of the examples I was talking about in the morning, how Google uses these things. I mean, see how many services we are using out of Google which are personal to us, which we have been using something else, but now we are using this. How much of change has happened within a very short period of time, right? Then optimize operations, reduce fraud, maximize insights, and get that edge over economic information, absolutely transform business performance and processes, and and this is something that we are talking about a lot these days, creating new business models, right? Now one of the biggest problems we have in Sri Lanka at the moment, and this is okay, so I mean I will not talk too much about it in terms of the geopolitics level, but one of the biggest concerns we have is uh, there are farmers who produce goods, there are economic centers who actually make it available for retailers and wholesalers, and there are end customers like you and me who want goods and services to be delivered. However, why is it that we still don't have a mechanism to do this? One of the biggest reasons is we have not really thought of using information as for new business modeling, right? I mean, there are so many things that you can do to make simple solutions available. Now, you and I, when we go to the supermarket or some place, we pay what, 280 rupees, 200 and almost 300 rupees per kilo for carrot. Okay, I will just use a very simple example: carrots, right? It's not rocket science, it's not golden carrots, no, it's just carrots, right? But we pay 300 rupees per kilo, right? However, if you really look at it from a different aspect, when you talk to farmers, they say we can't even sell our carrots. So what is the issue, right? Yes, there's a mafia, there are so many other things, but why isn't it that we are not using technology to bridge this issue? The reason is we have not one thing, we have not thought of a new business model with the data that we have, and plus we have not thought of out of our old boxes. We are still thinking we need to have an economic center, we need to have farmers bringing their things there, selling it there, ganna CI. Our thinking is still there. However, if you really look at how other countries actually look at these things, right, um, you can actually look at actually doing a business model where from the grower to the end customer, produce is available, right? There are solutions in the world. There are solutions in Sri Lanka that people are talking to the government to, can you promote this, can you get this done? But the thinking has to happen at the business model level. AI is one reason why AI is so popular in the world. Is all of a sudden people had uh, people had room, people had avenues, people had mechanisms to think of different business models, and this is why this is very interesting. This is an interesting subject, right? So if you look at the top 10 aviation models in the world, and I thought this will be interesting for you all because I think it's good that you all think about these things. The world is moving to green concepts, right? Green airports, right? If you look at Germany, if you look at the European region especially, and even some parts of Asia as well. If you look at Japan, if you look at Malaysia, especially Korea, they are moving to greener airports, right? Because the carbon footprint in an airport is extremely high, right? Or was high, now it's changing, shifting. So I think even you all must also be thinking about these things. Then ownership transitions, because operating an airport, operating terminals is a huge cost, and now we are thinking about ownership transitions. Airport cities, now we are thinking about what do you call a port city, and that's a concept that is actually very it's a concept that if you get it right will really work. If you get it wrong, you will absolutely mess it up. There are airport cities. If you look at Singapore, if you look at China, if you look at even certain parts of Europe, there are airport cities that are which are called aero aerotropolis in very simple terms, right? Location based services, consolidating the business model, digital security, self managed terminals. In US, pretty much everything is self-managed. There are hardly any people doing anything. People come, they can pretty much do everything on their own and get on the flight and go, right? Increasing the traffic, with especially after COVID, integration and standardization, and digital transformation, right? These are some of the trends. I don't want to go into each and every one and kind of dissect everything, but just wanted to give you like why AI becomes so important, and why database management and thinking databases in terms of the power of information is very important for us to think about, right? why it's valid. So we have about 10 minutes. I'll quickly touch on a few things. So we have moved away from data processing to now we are at data analytics, and now we are actually thinking about data driven decisions, right? That is why this segment is something that I want to talk about. No longer are we thinking of our database systems or solutions or software as data processing. We are actually thinking of them as data analytical models. How can we do data analytics through the interfaces that we have and through the people that we have, right? That's why people and processes are really a fundamental thing here now. And then data driven decisions, right? It's all about making decisions based on real time data, right? And then now we are going to talk about big data. So big data, some of the basics just to make sure everyone's on the same page. Big data is used to describe massive volume of data. It can be structured, unstructured. A human being cannot look at this data and actually process it, right? So you can't use traditional mechanisms, traditional systems, traditional thoughts to make use of this data. And the scary thing is this data has always been there. Okay, it's not like big data all of a sudden came from somewhere. Big data has always been there, but now we are looking at that data and really figuring out we can't use our old thinking to use this data, right? So books, music, videos, social media, everything gives information, creates big data. Okay. And the interesting thing is you can use all of them if you know what to do to make some really good decisions. Okay, so let me break down big data into 4 segments. You have unstructured data, semi-structured, structured data, and if you have structured data, life is pretty simple because manipulating and working with structured data is very easy. However, if you have semi-structured or unstructured data, which is 80% of data right now in the world, right, you can make some very interesting observations and you can really use them to make super business decisions. But because it's unstructured, people using traditional systems cannot use that data. That is why you need AI to come in and different. AI is a very large umbrella. There are small little segments that you need to think about. Why you need AI to help with unstructured data? Because structured data anyway, the standard models will work, but 80% of the data that is really crucial to make decisions is unstructured, right? And that's why we need to think about it. Yeah, so you think about things like volume, variety, velocity, veracity in terms of big data, and you can go through this slide a little. This is there in your book as well. You can go through this and you can figure out why. Now see, if you look at the volume of data, 30 billion pieces of content on Facebook every month. Okay, so just imagine, right? 4 billion hours of video are watched every month by people on YouTube. Okay, 1 in 3 businesses don't trust the information they have because they can't make sense of it. I mean, this is the real world. Okay, and this is what we need to really start thinking if you want to think about taking things to the next level. Because you need to really you need to appreciate that there are these concepts behind big data. It's not just people use this word big data, but I don't think many people understand what truly it has and how complex it is, and why you need decision support systems to be built thinking of these things, right? That's why I am focusing on this. You need to think in terms of big data, in terms of all of these complexities, and to build your systems around it, rather than thinking building something and then thinking we'll do big data. You can never do that, right? You need to think in terms of this, look at your processes in terms of volume, variety, veracity, velocity, and think how can we build a system, how can we enhance the systems we have to make use of this beautiful data that you have, which is amazing, right? Then the 7 V's of big data. I don't want to take you to all of that, but one of the critical things you need to think about is value, because this data has so much of value and it's going to waste right now. Okay, that is why some of the bigger companies in the world are spending money and effort and time to actually make use of this big data, because the business models they can come up with by looking at this data set is huge. Why is, okay, I'll use a simple example before we close for lunch. Look at Pick Me. Okay, 7 years ago or 8 years ago when Pick Me came, they were they yes, they totally changed how the taxi hailing application market works in Sri Lanka. We were not used to it. We were used to calling up, or uh, we are either getting a taxi from the road or calling up. If you wanted something a little bit more posh, you have to call, and hopefully they have something. If not, they put you on a booking, and then hopefully they'll come. You have no visibility, nothing. But they totally change how taxis are booked right now, right? You can get a really good vehicle just sitting at your desktop and typing in a few things on your application. But from that moment, see where they have taken it now, right? Look at how many, there's Pick Me Flash, that you can get stuff delivered, right? And that's an entire business model on its own. You have food delivery, right? Which is a total different business model of its own. You have a marketplace, a total different business model on its own. How did this start? This started because they started with a small application, started getting data, and they started looking at this data in terms of the value of the data. They realize, hold on, we have so much of data, we have so much of location information, we have so many products, we have so many people traveling. All of this, when you look at the dissected information as a whole, you realize the volume and the velocity and the value of this information. That is why I say, if you also, as the aviation industry, look at data in a different way, we will realize that there's so much of new business models we can come up with, right? So we will talk a little bit about all of them in our next segment. So let me just quickly close up with two things, right? So big data, you can either process it batch wise, you can actually process it stream wise also. Batch wise is more commonly used because it's a little cheaper. And you can run certain things without too much of a hassle, like payroll and things like that, right? You can run it with some level of control. Streamwise is also becoming very very popular now, because of the online nature of the work that we do, right? Fraud detection, bank transactions, blockchain. I'm not too sure. I didn't go to talk about blockchain today, but we can if you want to. Blockchain is a fancy concept that is derived out of derived along with AI and big data, right? So everyone, I think it's 12:30 now. Since we agreed to break for lunch, it's 12:29 actually. For lunch at 12:30, we'll break for lunch and we'll come back, and I'll just take you through some of the tools and the mechanisms and some of these funky solutions that people have come up with. I'm not talking about technical stuff, but we'll go into some details in terms of AI related data once we come back. So let's come back at 1 o'clock. Sorry, let's come back at 12:30 now. 1:30. I think 1 hour is what we agreed for. I'm okay with that if you are comfortable. So we'll come back at 1:30 and continue with our session. I would like to have a lot more interaction in our next session, because we are getting into some very interesting case studies, not major case studies, but examples from your industry itself. So please be ready and participate, be vocal. I'm going to thank the ones who are vocal on this session. Let's be very very much vocal next session as well, within the next session as well, and ensure that we walk away with some very good insights. Okay everyone, so we'll break for lunch and come back at 1:30. Thank you.